All right. Hello, everybody. Hi. So I'm going to go ahead and maybe get started. I think the pizza line is somewhat dying down. Just in case you have missed things, beer is back here and some drinks. Pizza, of course, is over on the other side. My name is Brian. I work for Continuum Analytics. Peter is on a plane right now, actually, so he can't be here. But I would like to thank everyone for making it out this month's APUG. Also, just to let everyone know, we will be having APUG next month. I know there's a lot of sort of madness and confusion going on around South by Southwest, but we will be having APUG next month, probably in the classroom. We'll probably have to cap attendance because of that. So just be aware that if you want to come next month, please do try to sign up early. Just what else I want to say? Of course, thank very much to the Capital Factory for providing this really fantastic space for us to meet every month and have our wonderful APUG meetings, learn a lot of things, see a lot of cool projects and a lot of things that people are working on, so that's really exciting. Beyond that, if you have parking validated, don't forget to get that validated if you're down there. And then pretty much just want to go ahead and say a few words about Continuum. So Continuum, by the way, is sponsoring tonight's APUG. That's why I get to stay up here. So that's why I get to stay up here and talk for a little bit longer, not too many minutes. But I just wanted to first say that if you're not familiar with Continuum, we are a local Python company based here in Austin. We've been growing really rapidly over the last 3 years. We really focus on data analytics and providing both open source and commercial tools and consulting around data analytics. We're actually going to be moving downtown very soon, which is really exciting, probably in the next few weeks. But also we're hiring. So if you guys are interested, please come talk to me or any of the other Continuum folks. There's several over there at the table. Especially interested in folks that are interested in or have skills in sort of front-end development. I know everyone wants front-end developers these days, but certainly if you have that, please come talk to us. If you also interested in sort of data science type roles, come talk to us. We're hiring anything that's interesting around sort of the Python data stack and analytics in Python. Feel free to come have a chat with us. We'd love to talk to you. Also, if you're interested in services and or products, we develop, like I said, a lot of tools for the Python world. So if you need to deploy a lot of Python code or now R code, we have commercial tools built upon Conda, things like Anaconda Server that help you manage large clusters and deploy software reliably to them, scientific stacks reliably to them. We also have things like Wakari Enterprise that let you have sort of shareable environments hosted that you can use through a web interface and have collaboration on your analytical workflows. So lots of exciting things going on. It's going to be a really exciting year. Peter was just messaging me from the plane that he just got back from a DARPA kickoff meeting for all the projects that we're working on for DARPA, and he's really excited. So it's going to be a really exciting year for us. If you'd like to come find out what we're doing, please come talk to us, or maybe come work with us, come talk to us as well. So without further ado, just mention the talks that are going on tonight. So tonight, if I can look at the schedule, we have Eddy Reyes up first. He's going to be giving a talk on Pytest, which I'm actually really excited about because I've been meaning to learn about Pytest for a long time and just have not had a chance to look at it. So he's going to shortcut that for me tonight. And then after that, Andrew Donahoe is here, and he's going to talk about Swift for Pythonistas. So Swift, if you're not familiar with it, is a language created by Apple. Please correct me, Andrew, if I'm wrong. Sort of the light version of Objective-C if you want to sort of develop apps, but don't want to dig into Objective-C's templates such as for. We'll get a lot more great information from Andrew. If we have time at the end for any lightning talks, if anyone's interested, please come find me. I'm going to be sitting right over there. Let me know if we have some time. We'll certainly could put in a few lightning talks at the end if we have time. Otherwise, I will go ahead and let Eddy get started. Thanks. I'll steal my beer back first.
Oh, yeah. I was totally about to. I'm kind of like not a super loud talker, so if I sort of get lower and lower, somebody tell me, hey, speak up, and I'll try to be loud.
There's a microphone.
I think, yeah, there is a microphone there.
Oh, well.
I mean, if you're not typing, it's good news, but if you're typing, it's...
On the bottom.
On the bottom. I'll just try to talk loud. So my name's Eddy Reyes, and I'm kind of nuts because I'm trying to endear myself to a bunch of people I don't know by talking about TDD, the least polarizing technical topic I can think of. And in case you're not familiar with what I'm talking about, TDD inspires strong reactions, from people like, it gets engineers calling other engineers unprofessional. And I don't want to get into that. my goal is to talk about TDD at a high level because I feel like it's often misrepresented in lots of presentations I see. And then I'm going to talk about doing it with Pytest in particular. So basically the way this is going to go is I'm going to talk about TDD at a high level, talk about Pytest and do a walkthrough, and if I have time, I'm going to talk about mocking with Pytest. So as I said, my goal isn't to shame people into doing TDD. It's not what I'm not trying to proselytize. I do it. If you do it, good. And I'll leave Uncle Bob Martin to do all the shaming. You know who he is. So very high level, TDD is a methodology of implementing software, right? It's a practice that you follow as you write software. It's not magic. It's not the silver bullet. Software doesn't stop being hard. It doesn't stop being software just because you do TDD. Sorry?
Speak up.
All right. Yeah, thanks. I'll try. It's not the only way that you can write software.
You keep going. You keep going. I'll fuck.
Yeah. It's not the only way to do good software, but if you follow it, you'll probably write pretty solid software. So test-driven development basically goes like this. You want to change something, so instead of changing it, you first write a unit test and you watch it fail, then you change the code until the test passes, and then make more changes. And the idea is you short-circuit that process so that your changes are as small as possible. Right, and then when you're writing unit tests, they're most effective when they're self-contained, when they don't depend on other things, and when they run fast. So the pitfall that I kept getting into when I started doing test-driven development is my natural flow. The way my brain worked is I'd just sort of start prototyping and playing around with code and experimenting, and then when I had some sort of critical mass of something that worked, I'd then try to productize it. And I found, at least speaking for myself personally, it was better if I would go through that process, understand what it is I need to do, then erase it all, and then start over once I know what I need to do, and then use test-driven development to write, clean code, tested code. So a test basically looks like this, and I took this straight out of Uncle Bob Martin. I think it's a good way to think about a test. There's some precondition, which is, given something, when X happens, and X is the thing you're trying, the thing you're testing, then something must be true. And that's essentially what every test boils down to. And, if you studied, the Dijkstra in the 80s and all these people that wanted to write all these formal proofs of programs, it looks an awful lot like this, actually. And basically what that means is your tests are a formal design specification of something that you're writing. So when you write tests, I think it's a good idea to keep in mind that your tests should be presented to someone as sort of like the spec of your program. Obviously, your program should be documented. It should be readable. But if you ever want to go into, if you ever wish, you can look into what are all the boundary cases of each piece of a program as you think about it. If your tests are readable and approachable and read like a design spec, then not only do they continue to test your code as you extend your code, but they're readable like a spec. So that's kind of a nice consequence of doing tests. So Python has a very rich set of tools for testing. There's many out there, and the standard library comes with the unit test package. And then there's nose tests, which has also been around for a while. But I'm going to talk about Pytest because I think Pytest, it's my favorite unit test framework. And I think Pytest comes with a set of tools that really helps you get at this format of presenting tests in a very clean way. And I'll show you what I mean by that in a second. So am I still speaking too low? Can you guys hear me in the back? Yeah? All right, good. So writing tests with Pytest, it's not like unit tests. You don't need to use classes. Pytest is reverse compatible with tests that you write with unit tests. So when you run the Pytest runner, it will also collect and run all your unit test stuff. So if you have a bunch of old tests in the old suite, it won't break Pytest, which is kind of nice. And Pytest, I mean, it really, really stretches the limits of Python's dynamism. It does some real crazy things with the language to get at the nice interface of writing tests that Pytest provides you. I try not to think about how they did these things because it makes my brain explode. It doesn't fit in my brain, but they pulled it off, and they really do some wacky things with Python to get it to look the way it does, as you'll see in a second. The other thing I really like about Pytest is that you can just use assert and give it a condition, and you don't got to use XUnit jargon like equal to and greater than. You just say assert something equals something, just like you would in a normal Python syntax, and it introspects it and figures it all out for you and gives you these nice reports, as you'll see in a second. So the real power of Pytest comes in fixtures, and fixtures are the same thing as setup teardown in the unit test world, the unit test package. Fixtures are basically functions that you define that return some object, and fixtures can depend on each other. And then a test in Pytest, which is what you see here on the right, can depend on fixtures. So in this particular test, this is testing the a Hello World Flask application, and it depends on a fixture called app client. So it's being passed in as an argument, but if you look over here, it's decorated by pytest.fixture. App client's a function, right? But Pytest does some wacky stuff under the covers so that when you say app client over here, you're actually getting the object that this function returns. And if you look closely at the app client fixture, it also depends on another fixture called app, right? And then app is what gives you the app object for the Flask application. And we're going to do a more in-depth Flask example in a second, so don't get all hung up on the Flask stuff. But this is sort of the basic structure of of Pytest fixtures and Pytest tests, the test cases themselves. Your functions basically start with test, and they can depend on any number of fixtures, as many as you like. The fixtures, as I mentioned, they're denoted by the fixture decorator. So doing this, when I used to write tests in unit test, I found that since it was classes and since it was setup and teardown, I ended up repeating a lot of boilerplate setup code and a lot of tests, and then I'm like, ooh, I'm violating dry. I don't like this. So then I played all these crazy tricks with inheritance and had test classes inherit other classes, and it was all pretty confusing. And I think I've never felt that concern anymore since I started writing Pytest test cases, because you can just stack these up arbitrarily as you like, and they all get cleaned up automatically. Dependencies are automatically resolved, and you just implement your fixture in one place for every test, which is nice. So we're going to jump into an example. So we're going to take Flask's Hello World, but we're going to use the TDD methodology to implement it with tests using Pytest. So our requirements, you can just look at flask.poku.org, and in the front page you can see what the Hello World Flask app looks like. We want to write a Flask app, and we want to have this hello route, so that when you hit the web service in whatever the root URL is /hello, you get a hello world message back. So a quite simple program. So at this point, this is what I was talking about before. If you get to this point and you're not sure, you don't know in your mind how you're going to implement this, at this point, TDD just doesn't really fit, at least it doesn't fit my mental process. What I would advise is stop TDD, go ahead and read and learn and experiment, build a prototype if you like, do whatever you want. However, if you want to follow TDD, I don't recommend that you commit that code, because then you'll have code and then you're going to retrofit tests to code, which while you get some tests, the tests they're just not going to be as well structured. They're not going to as comprehensively cover all the pieces of your program, because in TDD you're supposed to write the test and then you're supposed to write the code to fix the test. And it also ensures that your test is a comprehensive spec of your program, right? So what I'd recommend is you go off and you learn, and then you go and start doing TDD when you know exactly how what you're doing. You have a good mental model of how you're going to approach this problem, and then you're going to execute it. TDD will help you execute on this and help you write clean code that works as you understand it. Not to say that you won't have any logical errors, but. So we're going to start with a test. So the way I like to start is I just write an empty test, and I write my given when then in the PyDoc. And this test doesn't really do anything; it just asserts true. And then when we run it in the console, I always like to run Pytest with -v because it shows you each test that it's running with the result next to each test. And of course, this test is going to pass. This test doesn't really do anything. So it's a starting point, and it's an opportunity for you to get something down. So this is a Flask application, so we're going to need a Flask application. We're going to need the Flask app object. And are people here familiar with Flask? Or, yeah. If you're kind of lost about Flask, you can ask me, and I can backtrack and try to fill in whatever you don't understand about it. So there's a Python object for every Flask application, and this Python object has a test client that Flask provides you, and that's what I want to get at with these fixtures so that I can use it in my test. So I'm just going to go ahead and write these fixtures here, and basically the top one is just called app. That's going to find my Flask app, and it's going to return it. And then I have this other test client fixture that depends on my app fixture, and I'm just going to return the test client method. I could roll these into one fixture, but I'm doing it this way to illustrate that fixtures can depend on each other. And also in a bigger application, you might want to have the Flask app object by itself without the test client for some reason if you want to test something else in it. So if I run this, right, I only have a test file here. I don't have any hello app. That doesn't exist, so this is going to blow up. And then here's sort of where you get into the swing of the TDD sort of process. You got a failure, and then as developers, fixing failures just feels so natural. So it's like, oh, I know exactly what to do now. So I'm going to go and I'm going to write this hello app.py. And here I just did the bare minimum to make this test pass. I just created an app object, and now my test is happy again. Because if you look back, I'm importing hello app, which didn't exist at this point, and I'm taking this top level app object out of that module. So test is happy again. But we still don't have hello world. So we're going to add a little bit more logic to our test. So we're going to do a get on the hello route for our test client object. And we're going to pull out the data from that response. And I'm doing this in Python 3. So the data is bytes, and I'm turning it into something that's stringy so that I can compare it to a string safely. Those are details, but the basic idea of what this test is doing is he's doing a get on that route, and then he's making sure that that route gives me hello world. Right. So if I just go and run this as is, bam, we get another failure because we don't have a hello world route, obviously. So we got to go and fix this now. So we're going to go to our Flask app, and we're going to add a hello world route, and it's going to basically return the string hello world. And our test is happy now. It passed, right? So we've done the Flask hello world application with tests in Pytest using test-driven development. Does that make sense to everybody? Does anybody have any questions about anything I did there, or any? There's more coming. I went through this pretty fast. Yeah.
What would be the main difference using that same example with unit test?
Well, for unit tests, you would instead of doing this, you would have a class. Let's see, I can. I'm not at my computer, so I'm not going to try to write code. But basically, you'd have a class that would have a setup method that would basically create the test client and import your app, and then I would have a test method that would run these two lines. So basically, this stuff here gets done in your setup method. That's the main difference. And then this stuff here gets done in a test hello method inside a single class. For a small application like this, there isn't a huge difference, right? But then when you get into, when you have like a whole bunch of tests and they all require like, 2 of the 3 fixtures that you use in certain places, rather than repeating that or playing some inheritance games, you could just put up your fixtures all in one place and then you can just depend on them. And you can just get them as a need. Make sense? Any other questions so far?
Yeah, I'm just kind of wondering if you can talk about fixtures a little bit more. I'm just having a little bit of trouble wrapping my head around. Are they like your application model there, or are they just data objects?
Yeah, so fixtures in Pytest, they're if you read this, they're functions, right? But then you're passing in a function object into this thing. And that basically, at down at the code level of Pytest, that fixture decorator does quite a lot of magic to make that a lot more than just a function, basically. The net result is that when you access this object, here it's not the function, it's the thing that the function returns. And that's at the sort of nitty-gritty level, that's what a fixture is, right? At a high level, it's a dependency you want to inject into your application, right? It's a conceptual piece that you want to provide to your test, to do something that one or more tests may reuse. Right, make sense?
Yeah, sure. I come from Rails where fixtures are like YAML files and stuff like that.
Oh,
so just the nomenclature is a little bit tricky.
Okay, yeah, I can see that. Yeah. Any other questions so far?
Maybe you're going to cover this later. So, but is there a way to replace the teardown method of unit tests?
Yes, it's too bad I didn't show it here in the example, but Pytest has a super slick way to do it. There's two ways, actually, that Pytest gives you. One of them is if you depend on a special fixture called request, the request fixture has a method in it called add finalizer, and you can pass it a callback, and that's one way to do it. So then the Pytest guys, they do lots of wacky things, and they're like, that's too complicated, so they created a new type of fixture called a yield fixture. And the way the yield fixture works is you replace this decorator with a pytest.yield_fixture, and then instead of return, you yield back the object that that you want to give to your test. And then when your test returns, like it just continues from where the yield left off, and then put your cleanup code in there.
Nice.
Kind of nice, yeah. I think, yeah. So I think that's a lot nicer than Teardown. Any other questions? So, how am I doing on time? Am I doing? Oh,
21 minutes.
oh, yeah. I think I'm good then. So, real life is never that simple, right? Hello. If only everything was as easy as Hello World, right? We wouldn't be making the big bucks, right? So, what do programs really do? They connect to the network. They use databases. They open enormous gigabyte files. And then here you are trying to test your application, and you have code that needs to do all this stuff. And it's not very wieldy for tests, right? So here's where mocking comes in. And mocking is basically a testing technique where you trick your code into running things that's actually your test code, but it thinks it's calling out into the network. People refer to that as the edges of your application. You can also think of the edges of your application as external components that your application needs to communicate with. That could be the network, the database, some complicated configurations that a user could throw at you, large files, whatever. I mean, interfacing with the file system in any way, interfacing with the OS in any way. So there's a module in Python called mock, and there's a version of mock for Pytest. And if you're very used to using mock, you can use it in Pytest. But that's not what I'm going to talk about. I'm going to talk about a mechanism that comes with Pytest called monkey patch. And monkey patch is a lot more, it's a bit more crude than mock, but in my opinion, I think it's a little clearer, at least to me, what you're doing when you use monkey patch as opposed to using mock. So monkey patch is a fixture that comes with Pytest. It's a special fixture. And when you depend on it, you can call this setAttr method, and you can just give it any importable Python thing you can think of. You give it to it in a string right there, and you replace it with whatever function you want. And that's it. It's real simple and it's real crude. And basically when your code calls os.path.isLink, it's really calling your Lambda, and you better have the right number of arguments, and you better return something that won't blow up your code. That's up to you. That's where the rest of the logic will fit in, and we're going to see an example in a second. And then monkey patch symbols when the fixture gets cleaned up. So in other words, when your test exits and it goes and cleans, it does the cleanup for all the fixtures, it will restore os.path.isLink or os.path or whatever you're mocking. It will restore it back to whatever it was before. So now you can sort of build a mental model where fixtures are high-level dependencies that your application has, and basically you can use fixtures to encapsulate mocks, right? So you can have a test that depends on some fixture, and then that fixture can go ahead and mock stuff and, do all kinds of crazy stuff now. So, it preserves that whole, given when, then anatomy of a test that I like to, conceptualize a test as, and still do mocks, and largely leave your application code untouched, which I think is really neat. I understand that sometimes you got to change your application to facilitate tests, but Python is so dynamic, such a dynamic language, and Pytest gives you this monkey patch thing, or the mock, the mock framework. You can largely leave your code untouched, and your code will have no idea, that it's being mocked, which is kind of cool. So we're going to see an example of what that looks like. So we're going to take our Flask example application, and we're going to add a route that does a requests.get on Hacker News, and it's going to pull out the content encoding header of that reply. So obviously we do not want to talk to Hacker News in our test, especially if your CI system runs your test 50 times a minute. Hacker News isn't going to like you too much, so you want to mock that out. So basically we're going to write a new test, right? And we're going to depend on a new fixture, which we're going to look at in a second. And I break out the given when then, because that's how I like to think about each test that I write. Given that I have a Flask Hello app and a mock request handler, which is basically just enumerating the fixtures I'm depending on. When I do a get, I should get the value of content encoding returned back to me in a string. So I just went ahead and implemented this here, same test client that I used before, except I do a get on a different route, and I'm hoping to get back this string that I defined in my test called mock encoding, right? And then here's the actual mock itself. So at the bottom, there's a fixture called mock encoding request, and that depends on monkey patch. And monkey patch is going to replace requests.get with this function that I defined here, mock get, right? So mock get, it's going to take the same parameter that requests.get would normally receive, and I'm gonna make my test as tight as possible, and I'm gonna assert that you're passing in the URL that I expect you to pass in, and then I'm gonna return this object of my own invention called mock encoding response. And the only thing that does is it has an attribute called headers that has nothing but content encoding, and it's a dictionary that has my mock encoding constant as a value. So basically, this is just setting up all the scaffolding to fake out my program when he actually does a request.get into thinking he's doing request.get, but calling my thing that returns the thing that I expected to. And then my test is by checking that I get back this value that I made up. I know that this route called requests.get, and it called into my code. Yeah, you got a question?
Oh yeah, you had an assert in your mock function. Does Pytest do its assert magic on the mock function?
Absolutely, yes it does. Anything in the call stack that's within your test. So basically the call stack here is get, which is going to call into my Flask application.
So you can put asserts in your fixtures as well.
Oh yeah, absolutely. And it reports them nicely to you when they blow up. So yep. So that's my test, and my mock's in place. And I'm going to run the test, and he's going to blow up because I don't have a Hacker News encoding route. So I can just go ahead and go back to my Hello app, and I can import requests. And as you can see, this code has no idea that there's a mock or that there's any sort of test. You can read this code, and it's all right. He's doing request.get on news.ycombinator.com, and I'm going to pull out this field from the headers and return it to you. And then once I add this code, obviously my test is happy now. And I got two tests now that are passing. And that's basically it. I kind of flew through this. I hope I didn't go too fast and this made sense. And of course, I'm sorry?
Assert that the encoding is mock encoding?
Yes.
How did your test pass?
Yeah, so where's my assert? Here's my assert.
Oh,
Right.
that's also what your
Yeah, my monkey patch function returns. It basically has this headers field, right? That has mock encoding as the value of content encoding, and then this is request.get, the fake request.get. He returns this object. So if you look at the code, he takes the object returned by request.get, and he just pulls this field out of the headers dictionary.
to do anything that looks like a the real encoding of hacker news?
No, I mean, you don't have to, because this is all contained in your test code, and you want to make sure that what you want to make sure is that your program calls the interface that you want it to call, and that it will do the right thing with whatever the interface gives back to it. So when you mock something, it's a little bit counterintuitive, but you sort of take control of all that stuff. And you know what I said earlier about tests being specs, especially when you do all this mocking stuff, even more so your test becomes like just an assertion of, this is what I want my program to do. I'm not testing Hacker News, I'm not talking to Hacker News, and I'm not relying on Hacker News giving me anything, anything that my test needs in order to verify my program. What it's doing is that if I'm talking to Hacker News, I expect my program to try to get this header out of the response, and then assert that I'm basically getting what I expected to get out of the response. Assert that it got my thing from my fake request. Does that make sense?
So I guess maybe a more succinct way of putting that would be that you want to test one that you're requesting from Hacker News, and two, that whatever you get back from Hacker News, or the test in this case, is what your function returns.
Yes, thank you. Yeah, that's a much more succinct way of putting it. Yeah.
Could you just take a second to compare the output from a failed test with assert, with unit test versus with Pytest?
If I was on, let's see, I don't know whose computer this is.
So you have a screenshot of an output already. So
yeah. Let's see. Here's a passed test. Here's a failed test. And then let's see. I don't know if is there like a console here I can.
There is.
Yeah.
To the right side of the screen.
You got Python set up and all that?
Should be. Okay, 342 Anaconda for the win.
So can I write files into this directory here?
Screw it all you want.
All right.
It's my trash machine. It's a trash machine, so.
Let's go to 10. Yeah, so let's see. I'm a Linux user, so I don't. Do you have VI? Yeah, all right.
Apple Plus would preset.
Yeah. So,
could you enlarge your font a bit?
Apple Plus, believe me.
Apple Plus.
Yeah. There you go. Okay.
So everybody see that? All right. Yeah. I'm getting into serious trouble coding live in a presentation.
That's why you make no pressure, don't choke,
Yeah.
just relax. I'll be fine.
Yeah. Right. So let's see. Class test something. Then I think you have to inherit that test case. If somebody's done unit tests more recently than I have, please correct me.
Right.
Yeah. All right, good. So we're going to say test me, and then we're going to say self dot.
You take self as the first parameter in test mate.
Yes, I sure do. Thank you. And then it would be self dot what is it, equal or something like that?
Assert.
Assert. Yeah, assert true. False. All right. I've got this test.py thing, and then I think it's python-m unit test. Yeah, I don't believe that.
Lowercase test, I got the.
Sorry, say that again?
The method name.
Oh, yes, of course.
I think the method name needs to be lowercase test.
Yeah, I think it has to be lowercase test.
We're in here.
Yeah, there.
Yeah.
Yeah. So that's what a unit test failure looks like. And in comparison, comparison. Where's my failure? Yeah, that's pretty colors. You know.
If you use the assert keyword,
Yeah, you should just get a stack trace, I think, at that point, right? Like a, let's see.
Yeah, that's a pretty simple example too. If you were doing something where, let's say you're comparing items in a list, it'll actually dump out the contents of the list in a really pretty format. And it'll do some introspection on the data that you're comparing, and then it will show you what that is. It's much better.
Yeah. And Pytest.
Pytest does, yeah.
Pytest does this, yeah. Or you're saying that Pytest, I know Pytest does the introspection.
Yeah, that's what I mean. I assume everyone knew unit test did not do that.
Yes, that's right. Yes, that's right. Yeah. If I remember correctly, unit test doesn't do that. Yeah, I mean, if you let's try it. Actually, it should be pretty easy. Oh, but you don't do you have a virtual M or something?
Just it's Honda install Pytest. I'll move it all in.
So actually, if you just go back to your screenshot of your arrow output, you can actually see the introspection in your assert statement. So not this one, but the
other one. It shows like where the assert statement that it occurs there.
I think that one. See how do I present that? Yeah. So this is just a string. In a richer data structure like a list or a dict, it'll give you like actual diff. It looks like when you do a diff on two files, it'll do that on the data structure in the test output. Really nice. Yeah, this is a simple example, but it does dump the string that's wrong. And obviously, hello world ain't this string. And yeah, you can sort of see the diff output there. It's like this side has hello world and this other side has 404. So that's a little taste of what the diff output looks like. Yeah. Any other questions? Yeah.
So this is, I think, a pretty interesting example that you picked here, largely because you're consuming third-party data from somewhere on the internet, right? So a problem that I've run into in the past on applications where I'm doing something similar is that my target source, the data, the API, whatever, it moves out from underneath. And so I've been burned in the past by mocking things too much, where I'm not really testing my application code anymore. I'm kind of testing this other artificial structure I've created around my tests. Wondering if you have any kind of like a hygiene best practice type tips.
Yeah, so everything I've shown thus far are unit tests, right? I do not think unit tests are sufficient to fully test your application as a whole. There's functional tests. There people call it all sorts of things. I used to work in a place where there was functional tests and integration tests and system tests and blah blah blah. I think there's certainly a place to have written tests that go out and hit Hacker News at a very limited capacity, or that hit some external service doesn't make sense in order to detect exactly what you're describing. When something underneath you changes and then your code's now invalid, obviously your unit test won't catch that, but your code will break. Like somebody will catch it. Yeah, you want to catch it first, right?
Yeah, I'll say something to that too, which is one of the things that Pytest lets you do is a lot of times you'll define your fixtures in one file. It's usually, I think there's a special name for it, like Pytest Comm or something like that, which is configurable when you run your test. You can give it a different config file which has different fixtures. So one of your fixtures can mock out your integration points and the other one cannot. That way you can run your very quick unit test, and then if you decide, I really want to do a real run, use the other fixtures which don't mock, and then it'll run your test against the real endpoints.
To give you an anecdotal account of something similar, at one point I worked on embedded systems on cameras at life size, and I actually used Pytest to talk over a UART to the camera to test zoom and focus motors. And Pytest was not a unit test, but I had to do all sorts of crazy tracking of where my motor was, and things, tracking external dependencies that you don't normally do in a unit test. The whole fixture construct that Pytest gives you, it's kind of universal for a lot of tests. It's a way that I like to rationalize tests personally. So, sorry, I think I interrupted somebody who was saying something.
So when you're doing this kind of mocking, you're relying on the namespace matching up with what's in your tested code. So if you change your implementation, you could theoretically break your mocking, correct?
Yeah, and I want to break my mocking because I want to have a code change break my tests. Or vice versa, right? Have a test change break my code, because it's the whole it's the whole freshness. You know, if your test isn't in line with your code and your code's changing and your test is not, like, your tests are invalid, like they just lost most of their value. If I change my code to use something different or to get another attribute out of my, say, my response to get, you know, I did, you know, response.headers and then I do response.body or something, you know, but if I'm doing that and it breaks my mock, that means I didn't test that, right?
Right, but I'm talking about not only that, but say you use a different request library, and therefore the call looks slightly different.
Oh, you're talking about an actual namespace collision, something else called requests.
No, I'm saying instead of using one request library, you use a different one with a slightly different name. And it works the same way. It just works better for other cases. If you decide to switch to that library, you've broken all your tests.
Yes.
Right.
Yeah, that's correct. Yeah. This approach I'm using to mocking, it does miss something kind of subtle that I don't know if that's what you have in your head. Where if say that my mock is never called. I did structure my test in a way that if my mock is never called, I'm probably not going to get mock response back. So the test will probably break then, or I think mock encoding is what I called it. But if I don't structure a test in this careful way to make sure that it breaks if my mock isn't called, then yeah, that's a potential. That's something you should keep in mind if you use this approach to mocking. I think the mock framework has some other tools to help you with it. Like it asserts that the thing's called with these arguments rather than having depending on the consequence of the call, like I'm doing here.
The test too is defining that like as you were saying, like the TDD, that's the spec. That the spec you're coding to is request, or not socket or URL or something like that. So you have a very specific. This is where I forget. I don't take responsibility.
We got a minute and 30 seconds left.
Does Pytest have anything for integration or regression tests?
You can use Pytest to write integration tests, regression tests. I don't think it has anything inherent to specifically that, but you can use that approach of writing tests for integration. And I also want to say there's a lot of features that I didn't cover about Pytest. Like if you go to pytest.org, you can, they have excellent docs that describe all their features and all their stuff. You should take a look at that if you're interested in learning more about Pytest. I've used Pytest a lot. You can talk to me. Also, I can talk about more features, but I got 40 seconds left. Anybody have a 30-second question? 36, 35?
What's Pi stand for in Pytest?
I don't know. I don't know.
It was originally in the Pi project, so like Pi.
Yeah, maybe Pi. I don't know.
Notice test was established because the Pytest docs.
I think 2 pi makes cow.
Say that? Say it again?
I think 2 pi makes cow.
Pi makes cow. Yes. Yes. Yes.
All right. Thank you, Eddie. Thank you.
We should take a 5-minute break, get more pizza if there's any air, get some beers, etc.
Anything you want by way of introduction, Andrew? I was traveling too much last week, so that's why I'm done traveling home, so I did actually be here. No, it's not enough. Thought there were only PBRs.
Oh, you got the pro snap.
So now you're like this build. exceptionally useful APUG for me.
Okay, well, it's hard to cover a whole language, but what I really want people to feel done is that they can approach it and they know they're people like because there are three so somebody will probably be documentation is just incredible. It started off rock.
It's a red light. He just made it right. I can't believe it. Like, turn on. Whichever one has the light. Why do the people who only he says you don't want that light? Yeah, he just made it right. Alright, never stop. They give me what are you building cars?
So, first off, I really want to say thank you again to Eddy for doing his talk on Pytest and test driven development. I've actually been really interested in Pytest, so it was actually really, really awesome to sort of see how it works in the practice. So, yet another APUG has come through for me with some really valuable information. Next up, we have Andrew Donahoe. He's going to be talking about Swift for Pythonistas. Again, Swift is this language created by Apple. And the main thing is just regardless of sort of what you're doing in this space, there's a lot of help available from a lot of places in this meetup, other meetups, across Python, across the science world. So, without any further ado.
Thank you all for allowing me to speak on this Fern technology. We're going to talk a bit about the playground. I'm going to show you a project that I've been working on. We're going to talk about app architecture and MVC. So we don't have a lot of time, so let's just get going. A lot of people don't actually know me. Don't know that I'm responsible in many ways for SVG. You can blame me. For XHTML11, you can blame me. Okay. There are plenty of other things you can blame me for, but those are the two that you guys probably care about. Go ahead, lay it on. All right, I'm totally there with it. All right, totally there with it. Okay. Swift is Apple's type-safe auto-inferencing language. What that means is all of the syntactic noise that most of the C-derived languages have is hidden in function declarations. Much like in Python 3, you have function annotations where you define types. In Swift, almost all the type information is hidden in the exact same places or in class definitions. And then the auto-inferencing engines basically do what you're used to in Python, which is slots that have no type. Objects have type in Python, but slots have no type. Slots have type in Swift, but you don't have to know what it is most of the time. So Apple's got a lot of good documentation on this. I'm going to take a quick look at the Swift programming language. Or if you just Google, human Google, Swift programming language, Bing if you prefer, Yahoo if you must. Marissa's doing a good job. Marissa's doing a good job there. You know, they're not dead, okay? Okay, and so basically, you'll get that URL you saw on the screen there, and it takes you to Apple's development documentation, which is basically their whole book. It has a complete language guide and a language reference. You can download it into iBooks if you want. And more importantly, it has this tour. And I'm going to show you the tour because I've downloaded it as a playground. You can think of Apple's playground as IPython Notebook for Swift. So basically, if you're used to IPython Notebook, you want to write text, write code, that's what they're trying to create for you. Okay? They're not trying to compete with IPython Notebook per se, they're just trying to give you that kind of text code integrated environment. Okay? So let's go back to, so here's the same page downloaded as a Xcode project. So Xcode is Apple's IDE. All right. There's an IDE from a company called JetBrains called AppCode, which you can also use. There are reasons to use the AppCode stuff. I use Xcode. Xcode costs you, basically, if you're an iOS developer, $100 a year because you have to have an iOS license. Xcode itself is free if you don't ever want to put something on a real device. But if you want to put it on a real device, they charge you $100 a year. So anyway, just to show you, so hello, not world, but Austin, okay. And so basically it actually recompiled the whole page, okay, and put it up here. So it's not a REPL like you're used to, okay, except Python compiles too. All right, this is a more complex language than Python, and so the compilation steps are more visible because it's doing a lot of type work. Most important thing to note is they explicitly control mutability. Now, one of the reasons Python has problems beyond the GIL in multi-threading is because the culture of Python is everything is mutable first. And you have to work hard to make your code immutable so you can put it onto threads or to separate it into separate pieces. Apple, because every machine Apple ships now has at least 2 cores, and this machine has 4, Mac Pros have 24 cores. Right? And they want to make it easy in their language for people to do multiprocessing. So from the very beginning, you have this distinction of var, which means it's something you can assign to multiple times, and something that's let, which is a constant. You can assign to it once. if you assign objects to that, you can still do things to the object. You just can't put multiple objects on it. This becomes really important when you start throwing these objects onto queues. And throwing them onto queues is what you do in iOS. You basically want to get all your code off of what's called the main event loop, or the main run loop. You do all the work on the other cores, because the main run loop is where all the graphics and sound and interaction are coordinated between the OS and your app. And if you're sitting on that loop cranking code, then you get a slower user experience. So Apple wants to make it easy for you to get off that loop. And so mutability and controlling mutability is a key feature of the language. If you look at environments like Clojure, look at Go, these other environments that specifically focus on parallel computing and multiprocessing, mutability and versus immutability is one of the core features of the language. So this is one of the things that Python is hard to do in Python because it's so mutable. When you talk to core developers like Nick Coughlin, who was here in town for Pytexas 2 years ago, as well as here for SciPy, he talks about even if they change the GIL, most Python code would break because it's got all of these mutability assumptions into it. So this is a big culture shift you're going to get when you come to iOS, is that you're going to have to start dealing with mutability specifically, and in fact, the class hierarchies are inverted to what you think. In iOS, the higher part of the class, closer to the NS object, is immutable, and it only becomes mutable down in the leaves. And so the idea is things are immutable by default. And so that it makes it easier for you to throw them into other queues and bring them onto other processes. So in that spirit, you are almost always going to use the let keyword. You as Pythonistas are going to want to use the var keyword. Bad Pythonista. Bad Pythonista. Don't do the var keyword. Var keyword is bad. Okay, bad. Just like in Python, these items here, this is basic implicit typing. Okay, integer, float. You can explicitly type it, but you don't need to. That does a cast, basically. This is about taking syntactic noise off the table. Swift is all about taking syntactic noise off the table, and part of what a lot of people like about Python and Ruby are that because everything's dynamically typed, you have a lot less syntactic noise. One of the key virtues of Python is it's writing pseudocode, because all of the nonsense of typing is gone. Now the types are down there, but people can kid themselves if they're not there. Right. Let's keep going. You have string concatenation. You're used to seeing that. Much like the new format statement in Python, you have interpolation. Basically, you can put expressions in the middle of your strings. That's kind of nice. You basically have dictionaries and arrays, all that good standard stuff. Okay, so for example, and this is important. Arrays are typed. So this array is an array of strings, and only strings go in this. Nothing else will go in this, or it will catch you. And the reason is that there's, much like in C++ and other languages like that, we're going to iterate through this stuff and utilize a whole bunch of special functions that can do sorting, etc. So any array has sorting, and if it had different things in it, all of that fast sorting code and mapping codes and all those other things that work on collection classes would not work. And so you will have to change your style to make sure your arrays are single type. Now, Swift, like Python, has tuples. You put anything you want in a tuple. And it's primarily used, as you would expect, just like it is in Python, to return multiple values from functions. All right, so basically the kinds of patterns. Yes, sir?
So is an array of tuples a single type now?
Yes, it is. Be careful what you put in those tuples.
Sure.
But it is a type. Or rather, at compile time, it's seen as all of these decisions are made at compile time. None of these are made at runtime, except that they're going to execute against those assumptions. And if you violate those assumptions, you're in trouble. And I'm hoping we'll get time to show you some code where we explicitly use static or dynamic typing, or not dynamic typing, we use generic typing to directly manipulate memory. And it's a really nice thing to show how to get a bit more control than just malloc and free. Okay. So it's a way to get underneath what you would call the Python layer to get down to the Python layer. Or the C Python, whatever you call it. Control flow is what you'd expect. Okay. Why does this keep jumping around? Arrays can, fresh arrays can also be done in the shorthand notation. Control flow is what you'd expect. You have four enumerations. All right, so these use iterators. We don't have generators in Swift, but it is a functional language, and so you'll see things like maps and filters and stuff like that, things that we would do in a list comprehension or a set comprehension, etc. They're going to do in functional patterns on your environments. Okay. The next big thing, the other weird thing about Swift to most people who come to it from both dynamic environments and static compiled environments is the concept of the optional. The optional is a very simple idea in practice, can be cumbersome until you embrace it. Okay. What the optional is that it is a data type that may or may not be there. And it is boxed, and you have to explicitly unbox it and then make a choice of what you're going to do. But the compiler forces you to make that test. This is part of type safety. Objective-C solved this problem by letting you send an arbitrary message to nil. So what would happen is responses that return nil would trickle through your code all over the place. You wouldn't crash until, thousands of instructions later. And sometimes you never crashed, and it was frequently a good robustness thing. Think about when someone returns none from one of your Python methods, and you were expecting to get a list, and then you start sending some messages to it, you fall over, right? In Objective-C, you wouldn't fall over, nothing would happen, but you wouldn't fall over. That is a silent failure. Type-safe languages that want to use type to go fast, and Swift's called Swift because they want it to go fast. All right, so when they can get around dynamic collections, they can hard compile stuff. Optionals are part of how they make sure that they can go fast. Okay. As a switch statement, the enum, you can basically put anything in the case. Almost any expression can go in the case. And that makes it for extremely powerful switch statements. So it's an extremely nice feature. I haven't fully grokked how to use it well yet. Okay. But much like Python, you'll find you're doing a lot more with functions than you are with classes in Swift. And so when you're doing a lot with functions, switches and case statements show up a lot more often than they do in objects, where you let the object dispatch system handle the cases for you. Right? Yes, sir.
Do cases fall through, or do they break out?
They all break. There's no fall through. Fall through is evil. No Duff's devices for this switch statement. None of that. Okay. And you have to have a default. Here's a tuple return. They've adopted the pattern from Python of underbar for things you want to ignore. Okay, so as I said, Python, a lot of things from Python have been embraced in the Swift ethos. Not everything, but a lot. It has while loops, has do while. Python doesn't have do while. Apparently, Guido really hates do while. All right, you don't get that. You have here, this is a range 0 to 3, i.e. that's what ... less than 4, that's 0 to 3. If you wanted to include 4, you'd put a dot in place of the less than. That makes it a closed range as opposed to an open range. So the open range is kind of what you're used to in Python, okay, where that would be up to that number. Of course, good old-fashioned C loops, don't use them. Okay. Now, One of the key characteristics of Swift is that closures are primary. Functions are closures with names. That's the only distinction. Swift will have one-line functions that look a lot like lambdas. Those are actually full-fledged closures, and they're fully general, and basically they just have syntactic simplification to what are called trailing blocks that can make things look extremely compact. Because closures are primary, they are what the Lisp people like to call first-class objects. You can pass them around. In fact, you are expected to pass them around. This is how you do multiprocessing on iOS, is you put your stuff in blocks. They go on these queues. They come off the queues. You use what is called an embedded pattern, where you have the block and the block back to the main frame, main queue, main thread, all in one block. They solve the callback hell by encouraging you to do embedded blocks so that there was a strict relationship. Yes, sir?
What is being shown on the right-hand side?
On the right-hand side is this code executing.
So it's showing what happened in the last call of the function with the evaluation of the
So what's your first name?
Desmond.
Desmond? Okay, there. Hello, Desmond.
So the first line is using it twice.
Well, this is the function that's being defined. I can't really answer the question because I don't know why it's doing it twice. Okay. Okay. One of the most important things of public speaking is when you don't know, you tell them. Right? And I'll be happy to get back to you about it afterwards. But I don't know the answer right now. Okay.
I don't think it's doing it twice. I think, like in the next example, every line has the value to the right. So the line that evaluated returns something, it has the value to the right. Just like in the next one, you have a bunch of values.
Right, right. That's a great theory. It's probably the right theory. As I said, I don't know, but I like your theory. Okay, so now let's talk about function types. So this function calculates statistics, takes an array of ints in scores. It returns a tuple. This is a named tuple. It could also be anonymous tuples, but this is how you name your tuple: min:'int, max:'int, sum:'int. And just like with named tuples in Python, you can assign them to three variables that don't have those and use a positional assignment. But this becomes a very strongly typed return system. Now, what this becomes important over time because they support generic types. And so methods frequently have the same name and they are just specialized on type. Whereas in Python, you'd put an arbitrary object on there and you would execute and hope that you had the right duck typing going on and things wouldn't crash. In Swift, they make sure you put the right type and then they will specialize your methods. Okay. Variodic arguments if you want them. You have nested functions, so basically this is a closure, okay? Just like you're used to in Python. Turn on. I've only got 21 more minutes, and I want to show you code that I wrote because I understand it better than this code. Okay, and so you can ask me lots of questions about that. Here's an example of their functional programming. So numbers is an array, and all collections have a map function. And this is a closure. That's a tail closure, and they are not using any of the simplification syntax. But this can all be written down into space, curly brace, 3 times number, curly brace, and it's done. So they have a simplification syntax for one-liners, two-liners, no parameters, using numeric parameters, the whole host of what most people think of as a confusing set of syntactic sugar for the trailing blocks. But you'll start to see that what all it is sugar on a closure. Much like lambda is sugar on a closure, except it has very strict rules, right? Very strict rules in a way. Sorted numbers. So here's an example of a tail closure using numeric properties to sort this method, sort this array, and returns a sorted array. If this was a mutable array, then it would have numbers would support a dot sort with the exact same tail closure, and it would do it in place, exactly the same as arrays and lists on Python. Right? Python, the dot sort doesn't return the list to show that it's a mutable thing, and sorted takes an array as a function and returns a new array. Right? Yes?
Sorry, can you explain sorted a little more? So sorted is a function that's defined in Swift.
Yes.
And then this thing at the end is the anonymous function that gets past the sorted?
This tells it the order. Do you want the first property, the left-hand side, to be greater than the right-hand side? Okay, or if you want, and that's reverse, that's descending order. If you want it in ascending order, you flip the sign.
But is that like an argument sorted that's outside of the
Yes, this is tail block syntax. But it is important to realize that there is no difference underneath the covers. This is the exact same closure. Okay, I mean, I don't know how lambdas are implemented in Python, but they seem to have some very specific rules about them. Those don't apply here. I could actually have a very complex block here, and it just because it's the tail block is all that's necessary. Aaron.
Well, it says that this is the second argument to the function. That you could take that closing parentheses and move it to the end of the line.
Yeah, I could put a comma, parentheses around this. I would then also put in the parameters, etc. Just like I think is done here. Here's the map. Okay. Here's a complex map, and then here's the short form of the map, and then you can actually even get it smaller.
So the point of having this syntax read instead of putting it inside the parentheses, you put it outside, is that you could have a whole bunch of a whole block of code in there.
Whole block of other code that you know is all going to be packaged up and shipped, where it could be shipped into a GCD queue or to any other function. Has objects and classes. I've only got 17 minutes left, so two things to note. If you can initialize in your declaration, do so, otherwise you have to make an initializer. Okay, so you tend to only put things in initializers that you wish. This is an initializer that takes the named property string, named property name. Okay. We have, unlike Python, you specifically have to say that you're overriding a superclass function. And the reason is that lets the compiler know when it compiles your whole app, if anything subclasses the class. And if it doesn't, it can snap at compile time things into direct function calls. Direct function calls are fast. They're JSRs. Okay, versus going through vtable dispatch. If you all ever looked at message resolution order in Python, you know it's this huge hairball of code. Objective-C has a dynamic dispatch that's a hairball also. Without the override, they can't dispense with that. You had a question.
Does it only support single inheritance?
It's a single inheritance language with interfaces. So basically, Apple's had a lot of success with Objective-C with single inheritance with interfaces. Okay, yes, sir.
Why does that preclude you from doing multiple inheritance?
It doesn't, well, they designed their object model to run on top of the Objective-C model. And so, since that is a strict single inheritance model from the dawn of time, okay, that's what you get.
All right.
Okay. See, they've got millions of lines of code in the Cocoa framework. They are not walking away from that. They will evolve over time.
I hate multiple inheritance anyway.
Say again?
I hate multiple inheritance anyway, so it's okay.
Yeah. Good, I'm glad you're happy. Happiness is underrated. Yes, sir.
Can you tell us on the constructor, the very last line of that constructor you just It doesn't say let, it doesn't say var, and it doesn't say self.number of sides equals 4. So what does that mean?
Is this one here side length?
Yeah, the constructor, the very last line, number of sides equals
Number of sides equals 4. Okay.
Is that an implied self number of
Yes, there's an
sides?
implied self dot, but I'm not seeing the, oh, it's probably a named shape. So named shape is number of sides up there, so that's going all the way up. There's an implied
Those are just implicitly in the namespace of the functions.
Right. You can still use self dot to specialize. So I will frequently, in these optional statements, I'll say if let name of variable equals self dot same name of variable, and it unboxes it. And because of scoping rules, the name is safe. The name is safe because it only exists in that if statement. So this is again different than Python. That once you define something in Python, it's available for the whole function. Okay. There's no scoping in Python. Swift is strictly scoped. Any other questions? Okay, enumerations. Enumerations are explicitly supported. They can be arbitrary, again, arbitrary things. That makes them a much more useful feature. They support this subscripting model, so that as soon as it knows the type, you don't have to type out the class of the enumerator. And that is a special case of a struct. Okay, what is a struct? A struct is just like a C struct. Basically, it's a block of memory that has names associated with it. But unlike a C struct, they also have methods. They have behavior. But you cannot inherit a struct. So in other words, when you define this struct, it has a specific set of behaviors and that's it. And the reason that is because it is a C structure. It is a block of memory, has no vtable, etc. When you call one of these methods, the compiler is saying, okay, we're doing a function dispatch. All right. And so it happens that it's very nice in that whenever you have C language functions, you can pass these structures, pointers to structures. Underneath, everything doesn't change. When you need to go talk to the Unix kernel, underneath everything, the structure just flows. All right. And so this is an important part of Swift, is it's designed to be not just an application programming language, though that's what it is right now. It's designed in the fullness of time to be Apple's system programming language. Go all the way down into the kernel and back out. That's where they're going. That's why it has this tight integration with C, and it's all about compiling. Okay. And then, okay, so protocols and extensions. Okay, so protocols are what we call duck typing. All right. In the type world, you basically define a set of behavior, and in the Python world, you, fingers crossed, hope the behavior's there, right? I mean, quickly, how many people can tell me what's a file-like object in detail? See, it's this hazily defined thing. We have defined it explicitly, and that in essence becomes the same as duck typing. And I will show you an example of that when I get to my code. And then we come to generics, and we're not going to talk a lot about generics. And what you're going to start seeing is that you can start specializing on types, okay, and then create functions that are families of functions that execute against those types. And I'll show you very quickly one of those. Okay. So, as some of you know, many moons ago, now I wrote the first startup call app. Okay. Not that, I want that. And we are in co-working. Give me some co-working love. Okay, so this is a project that I've written that basically is mapping, it's tracking where you are. In this case, it's pushing data up to parse.com. So there's a whole bunch of networking stuff and database stuff, a whole bunch of stuff that goes on here. These pins are where you are. That's my house up there, and so you can see I've been tracking myself. And right now I'm experimenting with, will it turn the phone on and track me while I'm walking without opening the phone? That's the experiment I'm doing. But I wanted to show you what this app I'm about to show you is all about. Key thing to note, 3 tabs across the bottom, a map view, a location view. That went off to the cloud to get all the fixes. There's actually also a lot of extra encryption because when I did startup crawl, I got to see everybody's fixes. I know who was sleeping with whom. It was not a good thing. Okay. And so I'm doing a lot of experiment with crypto. Anyway, back to here. Yeah. Okay. Okay. So. When you write an iOS app, one of the first things you do is you write what's called an app delegate. In fact, the template writes it for you. And it's the place you go where all apps start. Okay, so all apps start here. And the reason I want to show this is this, so you can see what code written in Angular looks like, and also me learning things. Like I really don't need that self-configure parse, but I was writing it like it was Objective-C. I was doing line-by-line stuff. All right, I'll be taking that self out. Here you see me passing in, log in to the servers, and start with this block. And so basically, this goes off to the servers, does a login or a creation of the account. It's totally asynchronous. And basically, when it comes back, I say, okay, then turn on the fix collecting process. Once I have a user that's either auto logged in or real logged in, right? And that's an example of me passing a block to an arbitrary function of my own design, okay? That's nothing terribly deep there. Now, we look at all of this and, okay, it looks like kind of code. What does iOS code look like? Okay, so this is iOS code, all right? And it's doing things like getting that tab bar you saw, and the map view lives in a navigation controller, and I'm going to put that map icon on the tab bar. I'm going to go get the location view controller, the one that has the text, and then I've got a settings view controller, which I didn't show you, but here, so I'm putting all these pieces together. These lines of code do not look particularly different in Swift than in Objective-C or written in Python. They have, or written in Ruby. I've done this experiment with Ruby too. There's a Ruby motion environment. And basically I can take the semicolons off and take the type information out, and pretty much the code will almost always run in these type 3 languages. But the key point to recognize is that you look at all this code and your eyes glaze over, and the point is that the Cocoa framework is dense. It has a lot of capabilities, okay? And it's where you're going to spend your education time. The language is going to be comparatively simple to you, particularly if you're not getting into the generic stuff. You'll eventually get into the generic stuff, but you won't start there. And you're going to spend most of your learning iOS more than you might think. All right? Think of it this way. There are over 20,000 specific method calls in iOS. All right, if you think about, we think about the Python framework and like 27 things, well, there's probably 5,000 calls in the complete Python standard library. It's not that deep of an API. It's a very powerful API. I'm not dissing it, but it's not of the same caliber of stuff you have to get in your head. So what I'd like to show you in particular, though, is this app works, Swift is working fully with Objective-C. So the parse library is an Objective-C library. So I define the data types in the cloud utilizing Objective-C. Okay. So here I have, so this is the blob of data, it's some JSON that I encrypt and stuff like that. And these are the properties after I've encrypted them. So what's up in the cloud are these 4 things. This is Objective-C saying the property, what kind of object it is, all that sort of stuff, okay? I have an implementation file over here, and the only reason implementation is here is to parse the type, as well as to write some equality measures, okay? to basically let me do some equality mapping, okay? I bring that up just because I'm going to show you some generic code that utilizes that, okay? All right, so this code lives up in the cloud. Everybody's fixes and names and all that sort of stuff is encrypted with AES 256. It's totally over the top, military grade, all that sort of stuff. I don't want to know who's sleeping with who anymore. It's just no fun, okay? No fun at all, okay? It isn't, I assure you, it really isn't, okay? Particularly when they call you, it's no fun at all, okay? So I have this class called cached_location.swift. All right, and so a Swift file doesn't have a header and an implementation. Like Python, it's just one thing, okay? So this cache location, the whole reason the cache location exists is to crack open the encryption, unwrap the encryption so that I can easily use it in the UI, okay? And it's cached in that it keeps cracked open items in this private variable. They don't have class variables yet. If you try to make it a class variable, they say it's not here yet, go away. And so you go make it a global. But it does support name scoping, so nothing outside of this module can actually touch Dunder cache location. Okay. Basically, once you create this object with the location, you can't change it. That's what you want. That's why that's a let. These are vars because I'm using read-only characteristics, and that's a computed characteristic, and so they don't let me make constants be computed. That's a variable kind of concept. Here's an example of me taking a variable that is exclusively computed, okay, and it gives a getter, and this getter actually goes into the class, gets fixed, and pulls the coordinate out of it. And this is written explicitly to support the MK annotation. Because these cache locations are those pins you see dropping on the map. These MK annotations are those pins, okay? So here you see the hell that is optionals, okay? Except that this isn't a bad thing. This is the thing that's going to represent this encrypted thing from the cloud. I want it decrypted properly. I want it to fail if it doesn't decrypt properly. One of the most important rules of security programming is you want it to fail loudly. Silent failures suck. Silent failures are how hackers succeed. Right? So you want things to fail loudly. And so what we see here is I go get my location directory with Cipher data, I go get the data and I have an HMAC, it gives me back a dictionary, and I then go and say, get the fix out of the dictionary. If it doesn't come back, that's what this optional here means. Okay, if it doesn't come back, then give me a location that has invalid coordinates. All right. So in other words, I'm basically a belt and suspenders kind of guy here. If I have biometric verification, I use the Touch ID and a version of my stuff, okay? Where this is going is down here. These two functions down here is an overload of equals and less than. So you overload these two functions, and any array can now sort. Any container can now sort on cache location. Because I teach it in these methods, which are functions, not methods, they're functions, how exactly to do, and things are specialized exactly on the type. So left-hand side, right-hand side, here I call, go get the location and then use the Objective-C equals function to compare these two Objective-C items. But this is a Swift overload. Okay, it's actually a Swift overload on an Objective-C object written in Swift. Yes, sir.
Sorry, I don't know if you went over this syntax before, but does let have some trickiness to it?
Yes, this is unwrapping an optional. And so timestamp here may or may not be there. And so this is saying if the left-hand side timestamp is there, then let's go see, is the right-hand side timestamp there? If they are both there, then let's compare the left-hand, right-hand timestamp using earlier date. Whichever one comes back, is it equal to the left-hand side? All right. If so, then then I return the truth of whichever that is. If there is no if there is no right-hand side, well, I have this rule: missing timestamp, earliest date. All right. And so these two constants enforce that rule. Okay. Did I answer that question? Fantastic. All right. I've officially run out of time. I have exactly 5 minutes on the clock before Ashley comes and kicks my ass. Okay. Let me show you one more thing though. What show is here? Okay. So this function, okay. You saw the red line on the graph? That's called a polyline, okay? And so this polyline passes in a location, which could be anything. It's an array of things that support the MK annotation interface. It could be any object I pass in the future. This is in essence type duck typing, okay? So this could be any object I'm passing in, but this interface says I'm just depending in this function on the fact that it supports this interface. I'm now going to manipulate directly a C data structure. This is going to be a structure in memory. It's a block of memory that normally in the Objective-C code you would get with malloc. You would have to release it with free. So I'm going to create this array coordinates that is made out of an unsafe mutable pointer of this exact size. So that's the equivalent of size of, okay? And then that alloc.count, that's malloc, and that's the number you multiply times size of. Okay, so, but this is all a generic typed thing. Okay, this could be uint8, could be any size structure. Okay, it's got this really nice name, unsafe mutable pointer. It says Danger Will Robinson. Could just as easily say that, but that's what it means. Okay, we then go through this array, and this assignment here is banging directly into memory in a dynamic structure that isn't even defined. You finish it all up, and MK Polyline takes this C structure of coordinates, because that's what it wants. Because it comes from the bowels of the mapping system where everything has to be fast. It goes and gets it, and needs to know how long. It makes the polyline. Because it's allocated, I have to deallocate it, and then I return the polyline. So this is an example of generic typing at work. Okay. Yes, sir.
A question. If there, well, I don't even know if there are exceptions here, but if an exception gets raised before you get to the alloc, is there a language protection there or anything that would allow you to not leak the memory?
Exceptions are a developer time tool. Apple has built this environment in Objective-C as well as in Swift that exceptions are not to happen in delivered code. So in other words, exceptions and assertions you can put there, but you don't ship the code that does that. Those will be turned off typically in your release builds. All right. And the reason is pretty much you throw in an assertion because of the large mix of language models that existed on OS X where you had C++, you had C, you had Objective-C, you could have Pascal, you could have Fortran, you could have all of these things linked together. None of them have a common exception model. Not one of them. And so basically Apple solved that problem to say, verboten on the exceptions. Those do not ship to customers. So
for example, there, if you run out of memory, then coordinates gets a sort of a null pointer. If the alloc would return like a null, or your program would just die at that point, and yes. That's the end of it?
Yes.
I see.
Right. So if I was really a cool Swiftie, I'd put a question mark there, and that would force me to put it into an if around this, and then that assignment would get checked for nilness. So if I was a totally cool Swiftie, which I'm not yet, that's how I would solve that problem. Because it is a very real problem that you raised, but it's not going to be done with the exception mechanism. Did I answer your question?
Absolutely.
Okay, thanks. All right. Yes, sir.
Do you have to explicitly implement interfaces, or is it truly like duck typing where you just have the methods there and you can.
Well, MK annotation is defined, it's mapkit annotation, and so here it is.
Yeah.
Okay, and it's got this coordinate with the get, title, subtitle. In OS4, they introduced a setter for coordinate. Okay, but this was defined by Apple. It is not duck typing. This is a strongly type-safe language. So the real answer to your question is yes, you have to define it. But if you saw that array that's passed in an array of MK annotation, it's actually called with the complete cache location, an array of cache location, not
But
complete.
does that object need to explicitly declare that it's implementing an interface, or can it just implement that method?
It has to declare that it's implementing that method.
I see. So it's like jumping.
So here's an example of calling Polyline with locations. Locations is here. What is self.locations? Self.locations is an optional of an array of cache locations. A cache location is defined with an MK annotation.
Implements MK annotation.
Yeah. And not everything needs to be implemented in that. Three of those methods were optional, and only implemented one. Yes?
That MK annotation interface was declared in Swift. Is that something that they automatically generate?
Yes, they do that automatically.
It was done in Objective-C originally.
It is originally in Objective-C. It still is originally in Objective-C. They have machine translators that are translating it, but they are now also going in more carefully and annotating those translations so that it can be better used in Swift to exploit characteristics and force invariance on the frameworks, or at least capture the invariants that are coming out of the frameworks as they exist today, so that the compiler can make its own decisions about things. Okay. So basically, so for example, those two, that location and that user, those are written in Objective-C, yet they are visible in Swift with the exact same style. Okay. And there's a thing called the bridging table that you use to do that. Okay. So I'm officially out of time. I'm happy to stay or go have beer with people and talk more about things. Let me say that there are 3 iOS OS 10 groups in town. Okay, one meets here monthly. Meetup, go to meetup.com, type iOS in Austin. These 3 groups pop up. One meets weekly. That's called Cocoa Coders, and they are a traveling feast. They go to 4 different venues. One of which is here. They're mostly a northern-facing group. And then there's the South Austin iOS developers, and they meet in South Austin. Okay, so there are 3 groups that are all friendly. So if you want to go learn iOS stuff, feel free to join them. You know, I take questions. I teach beginning iPhone programming at ACC. It's a good thing. Okay, I think I'm teaching a class this spring. It hasn't made yet, so I don't know. If you all want to learn about SpriteKit and Swift, I'm teaching a class on that. Okay, so do animation with Swift. It's fun. So anyway, thank you very much.
All right, everyone. Yeah, very thankful for Andrew to come out and speak as well. It was really awesome. Just a few last words. Reminder: validate your parking. If you need to get it validated, please take your trash to appropriate place before we leave. And if you guys want to meet up and go have some beer, I encourage you guys, congregate. Maybe probably downstairs so we can clear out of the Capitol Factory. I have to go to bed early tonight. But thanks, everyone. Thanks to Continuum for the pizza. Thanks to Capitol Factory for the space, and everyone have a great evening.